we've got a bunch of data points, and in this case, our data points are just numbers on a number line, and we want to fit two Gaussians to them. So the way the EM algorithm works is you put the two Gaussians in two random positions in the space. So I got a yellow Gaussian and a blue Gaussian, and then you do something along the following lines. First, you compute the density, the probability that each of the Gaussians assigns to each of the data points. So the way to think about that is, imagine that you're sitting there in the back row and you're throwing darts at the blue Gaussian. Right? So what's the probability that it lands in x2? What's the probability that it lands in x10? Obviously, if you're throwing at the blue Gaussian and that's the variance, you would get a high number for x1 and x2 and a low number for x10. So you do it for the blue Gaussian, you do the same exact thing for the yellow Gaussian, all right? And then you plug the two numbers into Bayes' rule, and Bayes' rule gives you the posterior. So assuming that the dart landed at x1, is it more likely to be yellow or blue? That's what you get out of the posterior. And in this case, you expect x1 to be more likely out of yellow, and x2 to be more likely out of the blue, and x10 to be more likely out of the blue as well, even though it's very unlikely as an observation from either the yellow or the blue Gaussian. So if you plotted the posterior, it would look kind of like the sigmoid, so the dotted blue line. So that BI, the posterior, that the point came from the blue Gaussian, we're going to use it as a color. It's a number between 0 and 1, so if it's a 0, we're going to assume it's yellow. If it's 1, we're going to assume it's blue all the way. And for the numbers between, it's a mixture of yellow and blue. AI is the counterpart for the yellow Gaussian. It's just 1 minus BI. So I'm using those numbers as colors. Now the points are colored. All of the points starting with x3 and to the right, they're all going to be pretty much blue, and x1 and x2 are going to have some mixture of the blue and the yellow component. And then what I do is I re-estimate the means and the variances of the blue and the yellow Gaussian. And the way I do that is I take all the data points, I multiply them by what percentage, what proportion of blue they had in them, add it all up, divide by the blue posteriors, and that's going to be an estimate of my mean. And I estimate the variance in exactly the same way. I compute the differences between each point and the blue mean, so that line right there. I square those differences, multiply them by the amount of blue that you have in each case, and divide by the sum of the posteriors again. I do it for the blue Gaussian, I do the same exact thing for the yellow Gaussian, and after this, I'm going to have two new means and two new variances. So what you would expect to happen in this case, all of these points, starting with x3, are colored blue, so they're all, think of them as, they're all sort of assigned to the blue Gaussian. So the blue Gaussian will have a new mean in the midst of all of these points, and it will have a high variance because it's trying to cover all of those points that are now covered blue. So the blue Gaussian is going to have its mean somewhere in here, and it's going to be very wide. And the yellow Gaussian is going to remain pretty narrow because it's basically, its mean, only 2 points are mildly covered yellow, colored yellow, x1 and x2. So the mean is going to be somewhere in between them. x1 is a lot more yellow than x2. And the variance is going to be pretty small because it's not trying to cover any of those points. It's just trying to cover points x1 and x2. So the result might look like that. And based on these two Gaussians, you're going to compute a different posterior. So that's the blue dotted line. And that posterior assigns the colors. Now the colors are going to be spread out a little bit more. These points are going to be a little bit more yellow, and these points are definitely going to stay blue. So at the next iteration, the blue Gaussian is going to travel further to the left, and the yellow Gaussian will start capturing a little more points. So that's one possible way in which an algorithm could run. And these are the update equations in 1D. So this assumes that the priors for the two Gaussians remain fixed. The priors are the PA and the PB in the Bayes rule when I was computing the colors. You can either keep them fixed or you can re-estimate them at every step. If you re-estimate them, basically you allow different Gaussians to grab different amounts of data points. So the way you would re-estimate them is as follows. So for the prior of B, you add up all of the posteriors and divide by the total number of data points. That's an estimate of basically how much blue there was in the coloring related to the total number of data points. And PA is just how much yellow there was in the coloring.